What is data model? So data model is the collection of loaded tables of data. Simple, like I will again, give you a reference of whatever we have covered so far. So we are playing with the table. So data model is also a collection of tables. Data model is the collection of loaded tables of data with one or more columns that have been loaded for a reason. Don't load any columns for your source into your model unless you have a reason. So there should be a proper reason. If you want some calculation, if you want some data item, then load any column in your source file. Otherwise, don't need to load any extra columns. So loaded tables of data with one or more columns that you have been loaded. Yeah, in our source file, always we have more than one column. With one or more rows of data that have been loaded for a reason. Yes, we have so many rows. Sometimes we have hundreds of thousands of rows. Okay. So loaded tables of data. Number 2 is relationships between the loaded tables. So relationship we will study, we will see later on what are relationships. So for being data model, to create the relationship is a mandatory thing. If you don't establish the relationships, we will not call a model a data model unless there is a relationship. The third point is that the measures formulas written that apply the basic rules to the raw data to extract business insight. Example, sell price minus cost price is profit, including the. So data model is a collection of tables of data, relationships, and measures. So far, as of session 5, we have discussed the formulas as well, measures as well. We have seen the data tables, like we have seen different files with lot of data, different column, different rows. And the last thing which is missing is relationships, which we are going to establish now. So data model is quite simple. Why do I need a model? This is a question. So Power BI is a data model based BI reporting tool. Not all BI tools are data model based. So this is a condition that this Power BI which we are studying is a data model based BI reporting tool. Other traditional tools are like non-data model based. So one example of non-data model based BI tool is SQL Server Reporting Services, SSRS. So SSRS is a non-data model based BI tool. So I am sure you must have heard about this SQL Server Reporting. It's a non-data model based BI tool. Non-data model based BI reporting tools require the report writer to first generate a query to fetch the data from a database, typically SQL Server, and return the results of that query to SSRS so the results can be rendered in a report. I'm sure everybody, like all of you guys, must be working in an organization where there must be a guy who is a database administrator. He would be, working with SQL Server. So in the back end, whenever we want a report, that guy would be generating a Power Query with the help of SQL Server. So SQL Server is a non-data model based reporting tool, but Power BI is a data model based. So if you get expertise in Power BI, you no longer need the help of this SQL data server, because those servers are non-data model based. You will create a model on your own if you will get the expertise, and it's very simple. If you will create a data model, it will be an asset for you. So in Power BI, that's the advantage. Once you establish a model, you no longer need to depend on this SQL Server reporting, or some IT guy will be creating a will be generating a query, and then you need a report. Okay. So many non-data model based reporting tools have a user interface that helps in the generation of the query if you want to use it, or you can also use a scripting language like TSQL to fetch the data. So it's also like the same thing that many non-data model based reporting tools have other interfaces. So we will only talk about data model based reporting tool, which is Power BI. So a second example is Excel. Traditional Excel is also a non-data model based BI tool. By traditional Excel mean Excel the spreadsheet tool without the modern BI add-ins of Power Query and Power Pivot. So I'm sure that you guys must have seen that in the latest Excel there are some options of BI add-ins of Power Query and Power Pivot. So Excel is also a bit advanced now, but here we are talking about the traditional Excel, which does not have any data model based options. So in the case of traditional Excel, the user loads the data into the spreadsheet and then logically relates and aggregates the data using Excel formulas and builds a report. So it's very common that whenever we used to use the Excel, we used to create some formulas and we used to create some charts. So that's a traditional Excel. The biggest issue with a non-data model based reporting tools is that every time you need a report, you have to start again, often from scratch. Each report has a single purpose with very little usability or extensibility. So that's the thing I'm repeating in every session, that's the beauty of Power BI, that you don't need to repeat the laborious work, the same task again and again. The traditional non-data model-based tools we always need to have when we have to start a new project, when we have to start a new working, we need to start from the scratch. But here in this Power BI, which is a data model-based reporting tool, we don't need to start from the scratch. Once the model is there, you can just need to change the source file and you will have the output. Please silent mute your speakers. I think somebody is like okay. So the next slide is benefits of a data model. Nafis, can you please mute your mic? So the benefits of a data model. The benefits of a data model based tools like Power BI are: the author of the data model builds a reusable capability, the data model that can be used to solve the current reporting requirements as well as often future requirements without the need to go back and write further queries to retrieve a new subset of data. So again, the author of the data model is referring to you and to me, like we are the author. We will be the author of the data model which we are going to create. We build a reusable capability. Like once the data is there, it can be reused many times. And it's very easy. Number 2 point is the author can often be a business user, normally with good Excel skills. They don't have to be a professionally trained database administrator or SQL professional. Very, very important point. Like you guys, I myself, we are the business users. I also have the normal Excel skills. I am not a trained database administrator or SQL professional. In my organization, there are SQL database administrators. There are many people like this who have the expertise, but still we can, manage a data model easily. There is no need to refer to them. Sometimes I still remember that whenever we have to pull some data from our database, like from our ERP, we take the assistance of this database administrator, SQL guy. Yeah, we need this report. Can you help us? So once we, as a finance manager, as a finance leader, if we create a data model, we can refer to that data model again and again, and we don't need to be proficient or expert in SQL server or any other. The model is conceptual in nature, supported by a user-friendly interface that lets you build the model logically with the minimum of coding. You still need to do some coding, writing formulas for a good model, but no harder than your average Excel spreadsheet once you have the skill. So like, I am not a coder, I don't know coding, and I will be using some concepts to establish a data model. So you guys also are not expert in coding, so there is no need to be a coder. You can still write the formulas and you can create a very decent data model with the help of Power BI. Alright guys, now we will jump into the practical side. I hope it's clear. The theory will help you and we will refer back to the theory again and again, whatever we have covered. Okay?
Thank you.
It's clear.
Thank you. So now I will minimize this. I will refer back again to this to these slides.
Can we have the slides?
Yeah, sure. I prepared only for this session. Yeah.
Okay.
Session 6. So first I will show you my source data file. So this data file has multiple Excel sheets, and in the earlier sessions we discussed that when there are multiple sheets we have to use append query, merge query. But now with the help of data model, we no longer need to use this Power Query or append query or merge query. We create relationship between the tables and then we can use easily. So this is first table, sales data. This has some sales data, date, month, year, customer ID, customer gender, country, state, product category, product code, product order quantity. So it's very important. In this table we have order quantity. Okay. This is unit price. So in this table we have some information about the product and the unit price or sales price. The third table we have information about the cost. Code name is mentioned, product name is mentioned, and unit cost also mentioned. And in the last we have the product information. Product name is mentioned, code is mentioned. So this is a whole huge table column of product, and this is the code. Okay. So let me tell you what is the requirement or what kind of model I'm going to prepare. I will prepare a model in which I need the end report should contain total sales, total cost, margin, and margin percentage. So if this data is in front of you and you are the finance guy, you want to create a data model so that you will be using that model for the later use. What you will do? You will first import these sheets in Power BI, and then you will create the relationships, and then you will create the measures. So our requirement is that we want total sales, total cost, margin, and margin percentage. Remember, quantity is here, unit price is another table, cost price in another table, and product is another table. Although product is repeating in every table, the product is here as well, product is here as well, but we will create the relationships first. Okay. Control S, Control W, we will save and close this file, save. Now again we will pull this file in Power BI, and then we will do data model. Close Power BI desktop. I will open this. So our requirement is we want total sales, total cost, margin percentage, and our data is scattered. One column is in another table, unit cost in another table, unit price in another table. What we will do? Let's see. So the source file is in Excel. Again, get data, Excel. If the data is in Access, you can use Access. So section 6. This is my source file. Open. So I will again repeat the concept so that it will be easy for you guys when you will be doing practice. 4 tables with the blue header, 4 tables without the blue header. Again, the data was in tabular format. That's why the tables are coming with the blue header. And in either case, we will select the tables with the blue header. 1, 2, 3, 4. These were the 4 tables in 4 separate sheets. Cost price, product, sales data, unit cost. Transform data. Processing queries. So again, the first step is we have to check data type and transformation of data. So the first column is first table is cost price. Fine. Code is there, product is there, unit cost is there, data is valid. Product 2. The table number is 2. That's why it's giving the number 2. We will remove 2. Otherwise, it's fine. Sales data is the third table. Sales data 1 is the name, but I will keep it as sales data. So this is the big table. Date, month, year, customer ID, customer age. We will just have a walkthrough of the data so that you know if there is any problem. Frame size is empty. I will delete. And order quantity is very, very important. See, this order quantity is here. How can we get total sales and total cost unless we do some calculation? So order quantity is here in this sales data. I'm repeating this because I will refer back to when I will be doing calculations. I will tell you that we have order quantity in sales data. Okay. Unit price, code we have, product we have, unit price we have. Unit price or sales price, the same thing. Okay. So data is fine. If I want to reduce the number of columns, I will remove this month because again we have date column, so we no longer need this month column. Here I will remove. We want to keep as minimum as possible the number of columns. Fine. What we will do now? Close and apply, and we will go in Power BI. From Power Query, we will go to Power BI. So we don't need to do anything further in Power Query. All the operations will be performed now in Power BI. Close and apply. Applying query changes on all the tables. So now you guys must have noted that I have always selected this option report because this is the reporting interface. This one also we have seen. This is same like if you want to filter some data, this is data section or data icon. This is the modeling icon. Now we will use this modeling icon. Click on model. So there is some relationship already being created, so we will remove this. We will click on manage relationships, this icon, and we will remove all these relationships which has already been created because we will create on our own the new relationships. Delete. Delete. Do you want to delete this table relationships? Yes. Delete. Do you want to delete? Yes. Again delete. Do you want to delete? Yes. Delete. Yes. So there is no relationship in front of us. There are no relationships defined yet. Close. Now we will create the relationship. So I will just arrange the data. So to create the relationship, the first condition is that there should be a common column in each of the table. If there is no similar column, then there will be no relationship. So in this unit price, code is here, code is here, code is here, code is here, product code is here. So this sales data, it has the maximum number of columns, it has most data items. So this is the fact table, and this unit price, product and cost price are dimension tables. Okay, so we will create relationships between dimension tables to fact table. So from code, I will pick first code of this unit price, drag, select, drag and drop on product code. So the relationship is established between, just put the cursor on the pointer on this arrow, and then you will get to know that the relationship is established between code of unit price and product code of sales data. Now again, the code of product is here and the product code is here. Code. So the relationship established. Between code and code, and here again code with the code. Now the relationship established. This is our data model. There should be a common similar column in each of the table to create the relationship. It is similar to merge query. In the merge query, if you remember that we cannot merge unless we have a similar column. So we can say that the concept is same, but it's quite easy. In the merge query, we need to select one, and then it's checking that all the data items are there, and then it's a difficult process. But here it's quite simple. This is our data model. Now we will go back, and we can see that what else we can do. With the help of this data model, we can filter any data on our report. See this. This is sales data. I want product code from here. This is product code. I will take product from this product table because the relationship is already there, so I can filter any column, any tape from any table. This is the beauty. When the relationship was not there, I could not filter. So the product is there. Now I want total sales, total cost, margin and margin percentage. So if you remember that order quantity is here. So if I click here order quantity, it will give me order quantity. But to create the, to get the total sales, I need to multiply order quantity with unit price. To get total cost, I want to multiply unit cost with order quantity. And when I will get total cost, I can easily subtract sales cost from sales. I will get margin, and margin percentage will be quite easy. But order quantity is here in this column, in this table of sales data. Unit price is on a separate table, and unit cost on a separate table. What we will do? We will use measures. Okay. So as I told you before that, whenever we want to use some numbers and we want to create new measures, we create measures on their own. This order quantity is there, but we will convert this order quantity into a measure. Just I showed you in the last session. So when I converted the actual and budgets into measures, so that I could get the variance and various percentage. I just showed in front of you the recap of last session, that although I had the actual sales and budgeted sales with me, but I converted them into a measure form. So now again I will create this order quantity into the form of a measure, so that I can multiply order quantity with unit price, unit cost to get the required result. So again, new measure, total quantity is equal to, again, sum option, bracket open. So where is the total quantity? It's in the sales data table. There are 4 tables: cost, price, product, sales data, unit price. So the order quantity is there in the sales data table. So sales data is the heading and order quantity is there. So we have to search sales data and we will get this order quantity. I hope you got my point. This is how I will get order quantity, because we already have the relationship. We have created the relationship, so we can pull any data from any table. That's the beauty. Before that, when we were doing this, in Power Query, these calculations, it was difficult. Now in data modeling, it's quite simple. We already have created the relationship, so I can pull any column from any table. So that's what I have done now. Okay. So this order quantity I no longer need. This is the order quantity. I will uncheck this and I will click on the new order quantity. This is the quantity which I just created with the help of measure, total quantity. I will click, it's the total quantity now. Okay. I hope it's quite not very difficult, but when you will just focus on when you will do when you will have a when you will see the recording again, you will have more idea. But that's why I'm going a bit slow. So I will create a new folder of my measures, because I will be creating so many measures now. So enter data. I will give the heading of my measures. Load. One measure which I just created, I will transfer that measure into that folder or that table. My measures. So that is the measure I created, total quantity. I will just click, you have to click once. Here you will see name, total quantity. The new measure which I just created, home table should be my measures. And it will automatically transfer that measure into my heading, so that I will have the idea that how many measures I created and how many more I need to create. This is my measures, and this is the one which I just created. This is some extra column. Just delete this. Delete. Okay. So now my measures are separate, and there is only one measure I created, total quantity. All right. Now my next requirement is I want to create total sales. So as you people know that when we go in modeling, order quantity is here in this table and unit price is here in this table. Well, what should I do? How can I get the total sales unless I multiply these both? So again, I will use a new measure and I will use that measure. That measure is called SUMX and related option. So I will go back I will create new measure. Just focus. Just see the formula which I just showed. Total sales. I will do slowly. Total sales is equal to SUMX. This is the measure. Bracket open. So you see this table and expression. So first I need order quantity, total quantity, and then I need unit price. Okay. So order quantity is in sales data table. Sales data, comma, and then I will give the expression sales data order quantity multiply by related. This is the new tax measure, and I need unit price in a separate table, which is unit price, totals, bracket close. Now I got total sales, and I will transfer it into my measures, and I will repeat again what I have done. My measures, and I will drag and drop total sales. Just click once, comma. Okay, 95 million total sales. So what I did, just SUMX. This is the measure I used. The order quantity was in sales data table. Okay, and the unit price was in unit price table. If I go back in modeling, you have the idea that order quantity is here in this table of sales data, and unit price was in this unit price. This one was here in this unit price table. You got my point. One item which I need to have total sales is in a different table, which is order quantity. It's in sales data table, and the other one is in unit price table. If I go back, I use a measure which is called SUMX. First I got order quantity from sales data table. This is the table, this is the expression. This is the related tax. If our required items are in a different tables, we need to use this measure of related. Okay. Now I want total cost. Total cost, again I need order quantity. Order quantity is here in this sales data, and cost price and unit cost is in this table of cost price. Again I will use SUMX and related. Okay, I will go back, new measure. I need total cost is equal to SUMX, bracket open. See this table and expression. First I will go to table. Table name is sales data. So I will write sales data. It automatically gave me sales data. Then I have to give the expression. Expression is sales data order quantity multiply by, I will use related because I need cost, unit cost, which is on a separate in a different table. Related. Again, only column name. So this is the column name. Unit price is in cost price table. Bracket close. So it did the multiplication. Now I got the cost, total cost as well. Here is the total cost. I will first transfer it into my measures section. See this total sales, total. I created 3 measures as of now. Total quantity first I created this one, then total sales, this total cost, drag and drop. Total cost I got. Click once and comma. Fine. Now margin and margin percentage is a piece of cake. New measure. Margin is equal to total sales. It will already give me total sales easily, minus total cost. So simple. again I will total margin is here. I will shift margin into my measures. Then I will drag and drop here. Margin is here. Click once, one time click, comma. We will get the margin amount. Now margin percentage is the last requirement, and it's also very easy. New measure. Margin percent is equal to, we will use divide measure. I have repeated in today's recap as well. Divide we use. What is the formula of margin? Variance, margin divided by total sales. Okay, so margin I already calculated with the help of measure. It's coming with the bracket. Whenever we would have created any measure, it would come with a calculator sign. See this. Since the measure already created of this margin, so it's coming with the calculator sign. Divide margin, comma, with total sales. Total sales I already have created this. Again coming with the calculator sign, comma, 0. And I got the margin percentage as well, quite easy. Now again drag and drop. This is the margin percentage. Drag and drop here. And transfer margin percentage into my measures folder. Click margin percent once, and this is percent. So this is the required report which was the requirement. So simple. This is my asset. This is the model, my asset. This is the columns we have. This is the report. And I can use this model as many times I want. If the data is changed, the model will be there. Measures already there. If I want to create some visuals, I can easily create. If I want to see the sales country wise, because we have country data as well, I will click total sales. We have country data as well. Country. Total sales by country. Okay. Because the data which I had was in raw form. If you go back in Power Query, see this. The data was in raw form. We had cost price only. We had product name. We have sale price. We have quantity. But what we got with the help of measures and modeling, this output, which would not be possible unless we created the relationship and have the measures. This is our asset. This is the measures we created. We cannot have this result unless we have, unless we create the data models. And if I want to create measures, like if I want to create sales product wise, country wise, as many as I can create easily. So any questions, guys? It's a complete silent. I know it's quite heavy, but it should not be heavy because I've explained on a very in layman's language. I must say what I did, because when I took the classes, my sector was not that clear. I had to spend many nights on this to get to that sheet. See this. These are the measures. Total sales I got from this order quantity and unit price. Total cost I got from this order quantity and cost price, unit cost. And this is the final result. This is the measures. Total sales.
Thanks, Ali. Where did you created the model from? The table that you put in, and then you put arrows. Which menu did you use?
In model section.
Okay, so there was an icon for model.
Yeah, exactly. What I did, I will again tell you that I was here in the Power Query.
Yes.
You remember that was the first tab. When we pulled the Excel sheets, that was the first tab. We had cost price, product, sales data, unit price. Okay, I closed it. I checked the data types. I checked, checked data type. I did some transformation, and then I directly jumped into this in this screen. Then I click here, and I created the model relationship between this unit price code and sales data code. Then product code from the product column, and then this sales data column, and then these three relationships I created. This is one to many, one to many, one to many. We don't need to go into the debate of this. What is the meaning of this one to many? But it's simple, like this one item has been created relationship with these many items. Then in the reporting section, I created these measures, and the required result is in front of you. Sales, margin. So the answer to your question is that here in this section, model, here is a complete separate icon of this model. Here I created the relationships.
And where are you creating the measures from?
In this report section.
In the report.
In
And
the
which? Okay, and then you go new measure. Okay.
Yeah, new measure. Every time you click this, and you will get the heading in front of you, and then you can create the measures.
Right. Thank you.
So this is how it goes. This is a simple model I created. In the next section, I will create a complex model, and I will use time intelligence features as well. And I will pull prior year data quarter-wise, month-wise. There will be more data items. This is a simple data model. In the next session, I will have a complex one, and I will create a small dashboard as well.